Welcome to day 2 of Pi Week. This is Amazon's 15th birthday celebration. We had a great day yesterday. We had Pi with PEs. We had best practices for using S3, and we even had a launch, a 40% price reduction for S3 Glacier, making Glacier even better for modernizing backups from on-premises. Today, we're going to cover a little bit more about modern data lakes on AWS and S3, and the services we have to help enable data movement. We have a full day planned, so let's get started. This session is going to provide an overview of the challenges of the explosion of data and why AWS is the best place to build a data lake. The session following this one will dive into the best practices in building a data lake, how to get started with some use cases, and then we'll have some sessions on how to move data into AWS. So we know that data is a strategic asset for every organization, not just new businesses in gaming. Data has gone from being something that's cumbersome, expensive to store, difficult to manage, to becoming the lifeblood of many organizations. Over the past 7 years, a couple of key trends have got us to this point. Connected devices, mobile applications, and systems now generate more data than ever before. With the cloud driving down the cost of storage, customers no longer need to decide what data to keep and what data to throw away. With the cloud providing pay-as-you-go, on-demand compute, organizations can now more easily analyze their data to gain insights in a variety of different ways. So, if you're able to store every relevant data point about your business and have the ability to analyze all the data in different ways and distill the data down, it will fuel innovation in your organization, which can lead to a competitive advantage. Companies like yours today, they're using data to drive decisions like when to offer new product offerings, how to introduce new revenue streams, where to automate manual processes and earn customer trust. All these decisions can fuel innovation. For example, FINRA can catch fraud more effectively by processing exabytes of data on AWS. Bristol Myers Squibb uses analytics to discover, develop, and deliver new medicines that help patients prevail. But customers are facing new challenges in managing and analyzing their data. We hear from customers all the time. They're looking to extract more value from their data, but struggle to capture, store, analyze, and aggregate the data generated by today's businesses. Data is growing exponentially, coming from new sources, increasingly diverse, and needs to be securely accessed and analyzed by any number of applications and people. Data is the core behind every business decision that you have. Gartner states the #1 technology area where CIOs are increasing investment is BI, or data analytics. The same report shows 63% of CEOs say they're likely to make a change to the business model over the next 2 years. Analytics is a broad space, but some common use cases emerge from businesses. Most of your companies are pursuing some, if not all of these today, from big data analytics to data warehouse modernization, or operational search analytics. So what's happened over the last number of years is customers have accumulated so much data. A lot of data lives in silos. You probably have some data silos today in your organization. And it's really hard to do analytics when you have to go to all these different data silos. Customers are looking for a highly scalable, available, secure, and flexible data store, or a data lake that can handle extremely large amounts of data. With a data lake, customers can store all their structured and unstructured data using the open data format of their choice and tag their data in a central and searchable catalog. Going a step further, with a modern data architecture, you can combine all your data and query it in a place to generate meaningful cross-organizational insights. The lakehouse approach. It allows you a data warehouse that lives with one leg in the data lake and allows querying its data in place with no additional processing needed. You can run any type of analytics from historical reporting to machine learning-based predictive analytics efficiently without having to transform or move large amounts of data. And it's not just that. A modern data warehouse needs to answer a variety of requirements. Your users, for example, may be looking to perform predictive or operational analytics. Your data administrators and the owners want a single data catalog that is comprehensive and searchable. and industry-leading security and compliance that doesn't require additional costs. And your data engineers look for a broad ecosystem to ingest and transform data and automate infrastructure management through code. Many companies have taken all their data from various silos and aggregating all that data into one location, what many call a data lake. To do analytics and ML directly on top of that data, at other times, these same companies are storing other data in purpose-built data stores like a data warehouse to get quick results for complex queries on structured data, or in a search service to quickly search and analyze log data to monitor the health of production systems. As we see more and more companies using both data lakes and these purpose-built data stores, they oftentimes need to move data between these systems. For example, moving data from the lake to a purpose-built data store, from these stores to the lake, and between purpose-built data stores. We view these in three different approaches: inside out, outside in, and around the perimeter. Let's dig into each one of these concepts, and starting with inside out. Think of storing your data in your data lake and then moving a portion of that data to a purpose-built data store to do additional machine learning or analytics. This is the inside-out approach. Your data lives in a central data lake repository, and for specific use cases, you can move a portion of that data out to the analytics service for additional processing. For example, you may want to collect web clickstream data from your applications directly in the data lake, and then move a portion of that data out to a data warehouse for your daily reporting and dashboards. Now, let's look at an outside-in approach. In these situations, these companies are storing other data in purpose-built data stores, like a data warehouse, to get quick results for complex queries or structured data. Or in a search service to quickly search and analyze log data to monitor the health of production systems. And while you have data in purpose-built data stores like a data warehouse or search service, you may need to move some of that data into your data lake to do additional analysis and machine learning on it. Think of this as the outside-in approach. Your data lives in purpose-built data stores that are optimized to give you the performance and scale that you need. And you can move a portion of it into your data lake for additional processing when you want. For example, you may want to move the query results for sales of products in a given region from your data warehouse into your data lake to use machine learning to train product recommendations or different algorithms. Now, let's look around the perimeter, how data moves around your purpose-built data store. In many situations, you may want to move data from one purpose-built store, like your relational database, to another, like your data warehouse, or between your non-relational databases to a search service. Think of this as moving around the perimeter. This means being able to easily replicate and combine data from across these data stores. For example, your product catalog data is in your database, and you want to move it to a search service to make it easy to search your product catalog. So let's put these three approaches together. In order to achieve this, you'll need to build a modern data architecture that allows you to rapidly build a scalable data lake, using a broad and deep collection of purpose-built data services that provide the performance required for use cases like interactive dashboards and log analytics, enabling themselves to easily move data between the data lake and purpose-built data services, setting up governance and compliance in a unified way to secure, monitor, and manage your data, and choosing the cloud services that give you the low cost without compromising on performance or scale. We call this modern cloud-based analytics architecture, or the lakehouse architecture. It's not just about integrating your data lake and your data warehouse. It's about connecting your lake, your warehouse, and all your other purpose-built services into a coherent whole. Now, this is what it looks like in general. Let's talk about what the lakehouse architecture looks like on AWS. It starts with Amazon S3. Customers have been building data lakes on S3 longer than any cloud provider, as we're celebrating the 15th birthday today. And today, more data lakes run on AWS than anywhere else, and using Athena, an interactive query service, to analyze all their data. In addition to the data lake, customers use a combination of our purpose-built database and analytics services, like EMR, Amazon Elasticsearch Service, and Redshift, to ensure they're using the right tool for the job to get the high performance and scale at the lowest possible cost. To move their data between these systems, customers use AWS Glue, our serverless data integration service. And finally, they can use AWS Lake Formation to manage the security and governance of all their data, regardless of whether it sits in the data lake or in purpose-built data stores. And in all these cases, we've invested heavily in offering the best price performance out there. Let's dive in by discussing scalable data lakes, and by far, the most popular data lake infrastructure to build your foundation is Amazon S3. Why? Amazon S3 is the best place to build a data lake because it's unmatched durability, availability, and scalability. It has the best security, compliance, and audit capabilities. And has the fastest performance at the lowest cost. It offers 7 different storage classes at corresponding rates based on your performance needs, from standard all the way down to Glacier Deep Archive. It also offers S3 intelligent tiering, which automates the data movement based on access patterns. And S3 and AWS offer the most ways to bring data in and the most partner integrations. It's built to store and retrieve any amount of data, again, with unmatched availability and durability, built from the ground up to offer 11 nines of durability. Other unique capabilities of S3 include storing customer data in independent data centers across 3 availability zones within a single AWS region and automatically replicating data between any regions regardless of storage class. So why choose AWS for your data lake? AWS helps organizations quickly get from data to answers by providing mature and integrated analytics services ranging from cloud data warehouses to serverless data lakes. Getting answers quickly means spending less time building plumbing and configuring cloud analytics to working together. AWS helps you do this by giving you an easy path to cloud data lake and start running diverse analytic workloads. A secure cloud storage, compute, and network infrastructure that meets the specific needs of analytic workloads. And a fully integrated analytic stack with a mature set of analytic tools covering all common use cases and leveraging open source and standard languages, engines, and platforms, and the best performance, scalability, and lowest cost for analytics. AWS provides a diverse and mature set of analytic services that are deeply integrated with the infrastructure layer, allowing you to easily take advantage of features like S3 intelligent tiering and EC2 spot instances to reduce cost and run analytics faster. When you're ready for more advanced analytic approaches, AWS's collection of machine learning and AI services can be used against that same data in S3 to provide even more insight without delays and reduce costs from moving or transforming your data. To help customers migrate their data to the cloud, we've built a broad range of services and capabilities for you to use. For offline data transfer, we offer the AWS Snow family, which is comprised of AWS Snow Cone, AWS Snowball, and AWS Snowmobile. AWS Snow Cone and Snowball are purpose-built for use in edge locations where network capacity is constrained. AWS Snowmobile is an exabyte-scale data transfer service used to move massive amounts of volume of data to the cloud, or even a complete data center migration. For online data transfer, we offer AWS DataSync, which is an online data transfer service that simplifies, automates, and accelerates moving data between on-premise storage systems and AWS storage services, as well as between AWS storage services. You can even use Snowcone to collect, process, and move data to AWS online with AWS DataSync. Amazon S3 Transfer Acceleration makes public internet transfers to Amazon S3 faster, and the AWS Transfer family provides managed support for file transfers directly into and out of S3 with support for SFTP, FTPS, and FTP. For hybrid cloud storage, customers can use AWS Storage Gateway to connect and extend on-premises applications to AWS storage. Customers use Storage Gateway for moving backups to the cloud, using on-premises file shares backed by cloud storage, and providing low latency access to data in AWS for on-premises applications. We also offer an array of database migration and recovery services, as well as streaming data services like Amazon Kinesis to easily collect, process, and analyze video and data streams in real time. We know customer environments are complex, and that's why we offer the broadest set of cloud services for data movement and migration. And like I said earlier, more data lake and analytic customers have built their data lakes on AWS. Tens of thousands of data lakes run on AWS today across all industry and all sizes. So let's take a look at what we have planned for the rest of the day. We've got an action-packed agenda. We're going to talk about the AWS Lakehouse architecture and AWS Lake Formation, how to get started building a data lake in minutes, not months. Many of you heard about Amazon S3 Strong Consistency. It was launched at reInvent. You're going to hear from Pi with a PE, a principal engineer behind the launch of Strong Consistency, and answer some of the questions that may exist and talk about how that was built. We'll break down data silos, and we'll talk about more of the use cases of using S3 for a data lake, modernizing your data archive with Amazon S3 Glacier, accelerating your migration to S3, how to be successful in lift and shift migrations, and how to move to managed file storage with AWS File Solutions. That's all we have for my session today. Hopefully you guys stick around for the rest of Pi week, or for the Data Lake Day today, Security Day tomorrow, and we'll wrap it up with serverless on Thursday, and there could be some extra news on Thursday.
All right, Sean, thank you very much. You know, as I was watching that, I was wondering, when we take customers through this journey, can you talk a little bit about how kind of our partner network fits into this? You know, do you see some examples for recipes for success over there?
Yeah, I mean, like I said earlier, we have the deepest integration with partners out of any cloud provider. We work with Databricks, Snowflake, and just, you know, any other cloud data warehouse. And we've seen them, and we work closely with them every day. Customers use EMR, they use Snowflake, they use Databricks. It doesn't matter. You know, the foundation is built in S3, and it integrates with every partner.
Yeah, and just to be 100% clear, I mean, these use cases involve, you know, often they involve kind of hybrid migration scenarios where we kind of have to be able to leverage some of the capabilities, for example, with Direct Connect and our gateway capabilities and our outposts. It feels like that's been changing rapidly over the last couple of years. Is that kind of a focus area for the team?
Yeah, we just launched integration with Outpost this year, or late in 2020 rather, right? So we're seeing that pick up. We launched private link access, so even to really deepen the story from integrating with on-premises and moving from on-premises to S3 to kind of build out your data lake, moving some of that data from on-premise to S3, and then running machine learning with SageMaker for that data that you wouldn't have been able to do before. So it's kind of unlocking new use cases for us.
That's awesome. And can you share some of the indirect customer feedback that we've gotten from people who've used that so far?
Yeah, I think private link was one of the most requested features that we had for S3, and the uptake on that one has been phenomenal to date, right? It's only been in existence for mere weeks now, but the customer adoption and usage of that is phenomenal.
Yeah, that's awesome to hear. Well, Sean, thank you very much for your time and sharing this presentation with us.